For 100 years, the diesel engine ruled the road. 100 years of smoke, noise, oil changes, and fuel costs that went up every time someone in a foreign country decided to cut production. 100 years of the same basic technology: pistons, combustion, exhaust. And then quietly on a factory floor in Nevada, that era ended. Tesla didn't just build an electric truck, they built something that costs 70% less per mile to run, accelerates faster than a diesel at full load, and doesn't need a single drop of oil in its entire lifetime. And now, it's in mass production. Real trucks, real highways, real deliveries every single day. Today we're going to look at exactly what this truck does, what the real world numbers actually say, and why the diesel industry, a trillion-dollar industry, is facing something it has never faced before, an actual threat it cannot engineer its way out of. Let's start with some context, because to understand why this moment matters so much, you need to understand what diesel actually built. The first diesel-powered trucks appeared in the 1920s. By the 1950s, the American highway system was being constructed specifically to accommodate them. By the 1970s, trucking had become the literal backbone of the global supply chain. Today in the United States alone, there are roughly 2 million Class 8 semi-trucks on the road. They carry 72% of all freight by weight. Every product you buy, every piece of food, clothing, medicine, electronics, at some point in its journey, it was on a diesel truck. That's not a small industry, that's a $900 billion industry, and it runs almost entirely on diesel fuel. Now here's the problem with that: diesel prices are not stable. In 2022, diesel hit over $5.50 per gallon in the United States, the highest ever recorded. A single semi-truck driving 100,000 miles a year at 6 miles per gallon burns through roughly 16,000 gallons of diesel annually. At peak 2022 prices, that's nearly $90,000 in fuel costs per truck per year. And it's not just costs. The transportation sector is the largest source of greenhouse gas emissions in the United States. Heavy trucks, which are only about 5% of registered vehicles, produce nearly 25% of all transportation emissions. That's an extraordinary mismatch. Regulators have noticed, governments have noticed, and increasingly the companies that own those truck fleets have noticed too. The diesel era built the modern world, but its structural weaknesses, cost volatility, emissions, and aging technology have been accumulating for decades. The question was never whether it would be disrupted. The question was when and by what. When Elon Musk unveiled the Tesla Semi in November 2017, the trucking industry did not panic. It laughed. Industry veterans called it a PR stunt. Diesel manufacturers said the range claims were physically impossible with battery technology at the time. Analysts pointed out that the battery pack alone would weigh so much it would reduce cargo capacity to unusable levels. Musk said deliveries would start in 2019. They didn't. Then 2020, they didn't. The delays became a running joke. But here's what was actually happening during those years of silence. Tesla was solving problems that had never been solved before. How do you build a battery pack large enough to move 80,000 pounds for 500 miles without making the truck itself too heavy to be useful? How do you charge that battery fast enough that it doesn't destroy a driver's productivity? How do you cool 3 independent motors under sustained highway load without thermal failure? The answers required Tesla to develop entirely new battery cell technology, the 4680 cell, a larger format cell that stores more energy, costs less to manufacture per kilowatt hour, and handles heat better than previous generations. It took years, and when it was ready, everything changed. December 1st, 2022, Tesla quietly hands over the first production semis to PepsiCo at their Sparks, Nevada facility. No massive launch event, no celebrities, just trucks, keys, and drivers. And those trucks went straight to work the next morning. Now, in 2025, full mass production is underway. The factory line runs daily. The skeptics have gone quiet. The phrase mass production gets thrown around a lot, so let's be specific about what it actually means here, because it's more significant than it sounds. A prototype proves a concept. A pilot run of 50 trucks proves you can build something. Mass production means the manufacturing process itself is solved. It means supply chains are locked in. It means quality control systems are running. It means Tesla can build hundreds and eventually thousands of these trucks on a consistent schedule. At Giga, Nevada, Tesla's factory in Sparks, Nevada, an entire wing has been dedicated to semi-production. The factory uses high levels of automation. The 4,680 battery packs for the Semi are among the largest ever assembled for a production road vehicle. Getting that assembly process right at scale required entirely new tooling, new robotic systems, and new quality verification processes. Current production estimates from analysts tracking Tesla's factory output suggest Tesla is producing several hundred Semis per quarter, with a ramp-up trajectory towards several thousand units per year. That's not the end game. It's the starting point of a curve that historically, once Tesla's factories get moving, tends to accelerate faster than anyone predicts. For context, Tesla Model 3 production started at around 2,000 units per week in late 2017. By 2023, they were building over 20,000 per week. The Semi is at the bottom of that same curve right now. Now let's talk about the numbers, because this is where the Tesla Semi's case against diesel stops being a preference and starts being a financial argument that fleet operators cannot ignore. Operating cost per mile is the metric that matters most to freight companies. For a diesel Semi, that number typically sits between 38 and 45 cents per mile in fuel costs alone. And that's at normal diesel prices, not 2022 spike prices. For the Tesla Semi running on average US commercial electricity rates, that number drops to roughly 10 to 12 cents per mile. That is a 70 to 75% reduction in energy costs per mile. Now apply that to scale. A fleet of 100 trucks driving 100,000 miles each per year covers 10 million miles annually. At the diesel rate, that's $4 million per year in fuel. At the Tesla Semi rate, that's under $1.2 million. The difference, nearly $3 million per year, it goes straight back to the operating company every single year for the life of the fleet. Then add maintenance. Diesel engines require oil changes every 15,000 to 25,000 miles. Transmission fluid, coolant flushes, turbocharger maintenance, DEF fluid for emission systems, fuel filters, air filters. The average heavy-duty diesel truck costs somewhere between $15,000 and $20,000 per year in maintenance. Electric drive trains have a fraction of the moving parts. No oil, no transmission fluid. Regenerative braking extends brake pad life significantly. Industry estimates suggest electric heavy trucks cut lifetime maintenance costs by 30 to 40%. And then there's the range. Tesla claims over 500 miles per charge. Independent testing by PepsiCo drivers on real California routes with real loads confirmed consistent results between 400 and 500 miles. The average US freight route is around 250 miles. For most operations, one charge covers a full day's work, and the Megacharger adds 70 miles of range per minute, meaning a 30-minute driver break fully restores range for the next leg. These are not marketing claims anymore. These are operational realities being documented by actual fleet managers running actual routes. The strongest argument for the Tesla Semi isn't what Tesla says about it, it's who is writing checks for it. PepsiCo was first, 21 trucks delivered in December 2022, immediately put to work on California distribution routes. Their internal data, shared publicly, confirmed fuel savings of 60 to 70% per mile compared to their diesel fleet on the same routes. Drivers reported less fatigue, better visibility, and smoother handling. No major mechanical failures in the first year of operation. Walmart has orders in for 130 Tesla Semis. For a company that runs one of the largest private trucking fleets in the world, this is not an experiment. It's a strategic decision made by people whose job is to find every possible cent of operating efficiency. Amazon has committed to 100 units as part of their broader goal to electrify their delivery operations by 2030. Cisco, one of the largest food distribution companies in North America, has placed orders. UPS, DHL, and JB Hunt Transportation are all actively involved in evaluations and early orders. These companies did not reach their scale by making emotional decisions. They run exhaustive financial models before committing to any major fleet change. The fact that they are all moving in the same direction at the same time is one of the strongest signals available that the economics of electric freight are real, not projected, not theoretical, but verified. There's also a regulatory dimension that makes this less of a choice and more of an inevitability for certain operators. California, which sets emission standards that often become national standards, has mandated that all new heavy-duty trucks sold in the state must be zero emission by 2036. If you operate in California, this transition is not optional, it's scheduled. So what does this mean for the companies that have built their entire business on diesel trucks? Because Freightliner, Peterbilt, Kenworth, Volvo, Mack, these are not small operations. They have decades of engineering expertise, massive dealer networks, and deeply entrenched relationships with fleet operators. They are not standing still. Freightliner's eCascadia, Kenworth's T680E, Volvo's VNR Electric, these are real products already on roads. The traditional truck manufacturers are building electric trucks too, and they're building them with a century of understanding of how fleet operators actually work, what they need from a service network, and how to support trucks at scale across the country. But here's where Tesla has a structural advantage that is very difficult to close quickly. Tesla builds its own batteries, develops its own software, operates its own charging infrastructure, and sells direct to customers without a dealer network taking margin. That vertical integration means Tesla can move faster, cut costs more aggressively, and update vehicle software over the air in ways traditional manufacturers are still figuring out how to do. The analogy that keeps coming up is what happened to Nokia when the iPhone launched. Nokia wasn't a bad company, they weren't slow, they just didn't control the software layer, and when the software layer became the most important thing, their advantage in hardware manufacturing wasn't enough. The diesel manufacturers are not Nokia, but the structural parallel is worth taking seriously. Now, I want to be straight with you, because a fair analysis of this story has to include what isn't working yet. Charging infrastructure is the biggest unsolved problem. For depot-based operations, trucks that return to the same facility every night, megawatt chargers can be installed on site, and that works well. But for long-haul routes across multiple states, there are nowhere near enough public megawatt charging stations yet. A driver going from Chicago to Dallas needs to know they can charge reliably mid-route. Right now, that assurance doesn't fully exist. The upfront cost remains a real barrier. A diesel Semi costs between $150,000 and $200,000. The Tesla Semi is estimated at $250,000 or higher depending on configuration. For large fleet operators with capital access, the math still works over the vehicle's lifetime. For small independent operators, which make up a large portion of the trucking market, that gap is a genuine obstacle that financing alone doesn't always solve. Cold weather performance is a legitimate question mark. Batteries lose efficiency in extreme cold. Fleet operators in northern states and Canada are watching winter data closely, and that data is still being gathered. None of these are permanent problems. Infrastructure gets built, battery costs keep falling. Cold weather performance improves with software and thermal management updates. But they are real friction points that will slow adoption in certain segments of the market for the next several years. So here's where we actually are. Diesel trucks had a 100-year run, and they earned it. They built the supply chains that feed cities, supply hospitals, and stock every shelf you've ever bought something from. That's not nothing. That's a century of genuine, irreplaceable contribution to how the modern world works. But technology does not care about legacy. It cares about cost, efficiency, and scalability. And on every single one of those metrics, the Tesla Semi is winning. Not on paper anymore, but in documented real-world operational data collected by the hardest audience imaginable. Fortune 500 logistics companies whose margin depends on being right. Is diesel dead tomorrow? No. The transition will take years. The challenges are real, but the direction is set. The momentum is real, and the companies writing the biggest checks in the freight industry have already decided which way this goes. If this video gave you something to think about, hit the like button. It takes 1 second, and it genuinely helps this channel reach more people. If you want to stay ahead of the biggest shifts happening in technology and business, subscribe. I cover this space consistently and carefully, and I'd love to know what you think in the comments. Is diesel truly finished, or is there a future for it that we're not seeing? Drop your take below. I'll see you in the next one.